Section 32, Fire Alarms, Smoke Detectors, and Fire Pumps from the Canadian Electrical Code, Part 1. In this presentation, we're going to be looking at fire alarm requirements, as well as smoke and carbon monoxide alarms and fire pumps. The rules for fire alarm within the CEC are not specifically for the location or specific arrangement of components. Rather, they're very general in nature and a general overview of the requirements when it comes to conductors, raceways, and power supplies. 32100 covers the installation or the types of conductors. Notice they're all of copper and that they must be capable of carrying the load current. Remember, that could be over a vast distance, and so line drop at times will come into play, and this would also correlate and tie into different manufacturer specifications regarding how many amps different arrangements of devices will require. Below, we see a few images of FAS cable or fire alarm signal cable where we have unarmored and armored. 32100 also discusses the use of fiber optic. As this technology has advanced over the years, it's quite commonplace in larger installations to have a fire alarm transponder or larger fire alarm panels connected together through a fiber optic line. Prior to the introduction of this rule, it was necessary for installers to get a variance to allow for fiber optic to be used, as it was quite explicit that only copper could be. 32102 covers the wiring methods of fire alarm systems, and again, very general top-down approach. There are more specifics related to the installation of fire alarm conductors when it comes to Class A and DLCA and DLCB. Now, fire alarm systems are low voltage, Class 2. However, since they're life safety, they require installation in a protected manner. In general, fire alarm conductors must be installed in conduit or be of the armored type. There is, of course, an allowance in combustible construction or wood stud, where there are slight different requirements due to the type of wiring usually employed. It's not uncommon to see Lumex used for some of these fire alarm wiring installations. Some of you will be used to seeing red fittings, red conduit, or red painted cover plates. This is not a requirement by the CEC. However, it is good practice as it prevents future sharing of conduits as installations and alterations take place through the lifetime of the installation. 32104 discusses equipment bonding, and this is required in this section as since a fire alarm system is a Class 2 type circuit, the requirement for boxes and bonding is not nearly as stringent as when we are dealing with higher VA and higher voltage systems. So because it is a large system that is constructed throughout the building, 32104 states that we must still ensure that everything is bonded as per the normal Section 10 requirements. 32106 is a very general reference to the use of electrical supervision, which necessitates the installation of devices as individual terminations as opposed to parallel loops or skinning of the insulation and looping it under a single terminal. Of course, this is gone into in much more depth when we look at fire alarm systems specifically. 32108, the dedicated separate circuit, is required for a fire alarm panel. We don't want other items being supplied power by this circuit. And we'll notice that there are requirements as to the availability of that breaker to be locked off and also of the red color, something that makes it very obvious that this breaker should never be turned off, and one of the rare instances where we are encouraged, if not required, to lock the breaker in the on position rather than the off. Now, 32200 is related to residential installations only, and the smoke and carbon monoxide detectors we're looking at are the hardwired variety. Now, these detectors are not to be on dedicated circuits, which is a little bit different when compared to a fire alarm panel. And the reason for that is if they were and the breaker had tripped, nobody in a residential dwelling would typically even know because no one walks around their house looking for the slight intermittent blink of the red LED in a functioning fire detector. And so, if a fire were to occur, the detectors would be completely inoperable. Instead, we want to have these detectors connected onto a circuit that has at least lights, and it is restricted to be on a circuit that has no AFCI, GFCI, or switches upstream in the circuit. Most residential dwellings will require more than one smoke detector, and this requires then the installer to install 14.3 or 3 conductors between each one of the detectors. The red conductor is used to connect the communication lead together on each of the detectors, ensuring that all detectors will go into alarm if only one of them is triggered. Now, keep in mind, all of the detectors must, of course, be the same brand in order for that communication to function properly. The BC Fire Code provides details on the required locations of smoke and carbon monoxide detectors in residential dwellings, and typically we see that there is a smoke detector required on each level of the dwelling, as well as in each bedroom, and also in each hallway that provides entry to a bedroom. Fire pumps provide water pressure for on-site fire sprinkler systems within a commercial or retail building. They must be capable of operation under any emergency condition, power failure, main service damage, or even a fire. And so due to this, the requirements within some of the rules at the end of Section 32 are more on the extreme end of ensuring that the motor continues to turn the pump, as opposed to the typical rules that would try to protect the motor from an overcurrent condition. This is an example of a single line diagram for a fire pump with no emergency generator, which might be used in a smaller warehouse or a facility that is not required to have an emergency generator on site. It could look something like this, where we have a separate fire pump service going into a fire pump controller, and you'll notice that the wiring method for the installation of the conductors is much more robust and highly protected to ensure that even in an emergency situation, the conductors remain intact and providing power to the fire pump. Here's an example of a full fire pump installation with an emergency generator. Let's take a look at some of the rules relating to this. First off, one that we've already alluded to is that fire pumps are permitted to have their own separate supply service. And this is to ensure that even if the mains power supply were to be turned off, either by fire personnel or through damage, that this one still provides power to the fire pump in the event of an emergency and a fire in the building. The circuit breaker rating that is installed in this must be capable of allowing the motor to run under locked rotor conditions indefinitely, which is an item or a requirement that is fairly uncommon when it comes to motor installations. The purpose behind this rule is to ensure that the fire pump is able to run no matter what, even if it's only capable of putting out half the horsepower due to it being damaged. We still want it moving because water flowing through the sprinkler pipes is more important than saving the motor. The circuit breaker for the fire pump is permitted on the emergency generator side to be connected upstream of or bypass the main emergency generator circuit breaker. And so what you'll notice here is that this is meant to uh, show the surrounding boundary of the termination box for the emergency generator. And most emergency generators will have their own mains breaker located in the termination box. On many of them, there is a allowable connection on the supply side of this breaker that allows for us to connect a fire pump circuit breaker to it. And the reason for that is it prevents any sort of selective coordination problems or any sort of issue where this may trip. We want this to continue running. Now, Notice it goes down to a transfer switch, and the transfer switch down to the controller. In addition to having a very large overcurrent, there is no overload protection, no overloads in the fire pump motor controller. And due to this, the motor is intended to continue operating even in an overload condition. Finally, each fire pump must have its own separate transfer switch. If we have 5 fire pumps, we have 5 transfer switches. And this is again redundancy to ensure that if one transfer switch were to fail, the remaining pumps would still function. Fire pumps are a fairly integral component to a large fire suppression and mitigation system, and their correct wiring is imperative to ensure that loss of life does not result from a fire breaking out.